Let's try generating P, compiling it, and inserting a virtual domain. Then, after inserting the virtual domain, let's try package capture. So, the AP work order is first, design of a hawk, second, generator, so manifest pass, third, coding, writing user code, fourth, build, fifth, issue. What do you do before that? Copy, create, go live, and then sixth, yes, it's like this. I'll try this and finish today. So first, let's copy the comp basic file location in AUTOSAR AU2 here. Now, let's copy it and press enter. Did you do getter? You did getter, and it becomes a file. And the next thing to do is, in the compsa basic example, delete the subfolders under the folder I created like this. I copied the two folders containing the jetted files to this path. I copied them like this. After copying, we'll build it. Build. So, for example, in the case of VS Code, if you right-click on the folder, you can open a terminal in that folder. It's open, right? Once you open it, right-click and choose Open Integrates Terminal. You can open it in that folder. The first thing we do is, we need to start the compiler path compiler environment. This will change the appearance. Then, through the terminal, we type mkr build dbuild remake ding ding make, and it's done. Then, we'll do the same for Pro. So now, I'll show you how to copy the files so that you can copy them to the actual issue. First, when copying the files, we need to check the library side, so we need to check which libraries Scalin and Proxy are actually using. So, if you look at the data, I'll tell you here. If you drop it into the proxy of LED1 in the created folder proxy, the actual application will start and a list of libraries that it needs to use will appear. You must copy this library to perform normally in the virtual environment. So, if I show you the library list and explain, we've built up to number 4 now. What's important today is that the target is also creating a folder for copying. So, if I explain the library a little bit, what is ARA-Core? It's called the platform ARA-Core. What is ARA-Com? It's called the platform ARA-Com. The actual function cluster is a library file. If I explain it a little bit, I'll make it easy to understand. This is a bit important, but the term function cluster is now used on some platforms. For platforms like Crash, we use the term base-off-ware, but Play Home uses the term function cluster. This is a library. So, to use Araco, you need Araco Live. To use Arai, you need ARA and ARA-Com. Those three are essential, and as a proprietary feature of the company, we also have a third-party Mechasem library called Para. This exists. So, what exactly is a function class? It's an include file and a library. It consists of a header file and a library. When running an application, this library is used, and the platform-level application for each cushion class is defined in the standard. For example, CM, RGM, PHM, and PHMIM are defined. So, now that we have the tools we need, what else is needed to run P concurrently? It's CM. Yes, we need it. We need CM. First, let's create a folder. So, if you click here, you can create one in the left pane. So, I'll create a sample folder like this in the D workspace. It looks like this. So, let me briefly explain the folder structure. Here, the company's product features are binfold, etc., and so on. What I mean is, this is what I'm explaining right now. If you look here, I've created a folder. This is one machine, one platform, binfold, etc. folder, and bar folder. These three folder structures are specific to the company's product and must exist. So, let's create KDR. It looks like this. Next, in the bar folder, there's something called array. It's an arraign channel. Inside arraign, you'll find the computer and exec folders, which are created like this. And inside the bar folder, there's a logos folder. So, if you look at it like this, it should be created in the above folder structure. So, if you look at it like this, the application of the platform on a machine should all exist in the empty folder. I've seen other companies' products, and they're all similar. So, the SIP AutoZone should exist in the empty folder. Next is the manifest file, the ISI cushion manifest, the service instance manifest, the machine manifest. Yes, each of these manifest files must exist. When executing an application, in the case of that company's product, when CM and M operate, CM and active off channel are communicated through internal IPC. Currently, a socket file is created here in the form of a struct file, and a socket file is created in the EXC, and the CN and this AU communicate with that socket file. What I mean is, it's the computer in the bar, right? What's the reason? CM uses internal IPC Unix domain socket files for communication. Therefore, a Unix domain socket file is created here in the holder hierarchical structure, and EMCM communicates using that socket file. This is how the structure is fixed. Other companies use either the shared by pass method or the Unix domain method for IPC-level IPC communication. So, if you're wondering which is better, our company is currently considering replacing some memory. There are pros and cons, so we need to create this folder. Then, we copy the executable file. In the empty folder, the executable file is located here. Using the copy command, we copy what we built in the proxy build earlier. This file is copied here. Next, we go to the skeleton and copy it from the copy skeleton. We copied it from the proxy skeleton. You can copy it like this. So, in the news, you can copy using the cp command like this person. You can copy it like this. Next is the cm command. As for cm, that coffee company is putting cm in STK and shipping it. So, if you go to the path, it's fixed. If you go to this public road and do find cm, you'll find the cm. Here, you copy this CM into an empty folder. So, I went in like this and created it. I copied CM. So now there's CM and a proxy sketch. Did I finish copying this? Yes, it's done. Now, depending on which executable file you put here, the Explorer itself is a platform. You can add and remove the AA that's running there. Now, you just copy the executable file. I copied the CM proxy sketch, but the important thing is that just having the executable file doesn't make it run. You need to copy the manifest file. Where is the manifest file? The manifest file is in the jetted file. So, first, let's copy the manifest file. The interface is here, right? Using the interface copy name, since it's a holder, we'll copy it to the holder, so we'll use R for copy. After R, if it's empty here, it's copied. You can use the copy name or drag the mouse. So, to summarize, I copied the tab pass in the copy name. Now, I've copied the service entity manifest. Next, we need to copy this security manifest machine magic. As you can see, there's a security information under the machine folder. So, if that's all I have to do, I'll explain it based on the Zenith criteria. Then, the interface is copied to the etc. folder. In the case of a GUI ring piece, this is copied to the etc. folder. This is not it. This is not it. It is copied. Next, the machine path is a bit complicated to copy, but this is machine copied, and then below A is machine. So it becomes like this. When I put it in the chat window, I will just copy it without using the copy text. If I copy it here and put it in etc. high, it goes into the machine. It went into the machine, and I cut the Ishi cushion earlier and pasted it here. And here, I also copy the function group. I copied the group function group and put it in. It has to be like this. So, because that can be confusing, I provided the normally copied information yesterday by copying it into a tarpaulin with compy basic. If you compress the compy basic start file, you can see the structure. So, if I compare it to a comsa basic, here, in the etc. folder, there's a machine. It's structured like this. Therefore, it's important to understand the rules and copy them carefully, rather than just copying them from the Z folder. So, what I mean by this is, you really need to copy the main path file carefully. If you don't manage the history of the main path file and use an old version, or if you copy the manifest file from another application, it won't work properly. Lastly, you need to copy the library, right? See this? If you go to SK, you'll find the library you need. If you type find and era, the library is located here. The reason why finding the library is important is because there's an IJPers class library provided by that company, and there are I-related libraries regardless of the company. After I build and code the application, I have to manually search and find the I-related library. That's because information about application development libraries isn't readily available. Because it isn't, I have to find and copy them myself. So, after checking the library path, I can copy the library using the copy command. Let's copy the library. First, you need a library folder. You can name the folder whatever you want. So, let's copy this library by copying it, right? Copying it like this will copy one library. It's copied like this. Then, pressing the Tab key will autocomplete. Okay? Next, you can see the archive and then the DLT. DLT, DLT, and then the archive are copied. So, when you open an application, you don't just run that one application. You have to find all the libraries you want to use on that platform and copy them like this. That's it. They're all listed like this. Just like the one above, they're listed like this. And this may change depending on the open source or other libraries you use. For your reference, let me explain each one. When selling a JESA tool, vendor tool, Ericom, how much is ACO, how much is R, etc., they sell it like this. That's why Arrival is expensive. You guys are providing education to universities, and it's 100% identical to the rivals that are actually mass-produced. The unit price is expensive, unifying it. It's the price of an expensive apartment in Seoul. Just for your reference, however, large companies are boldly providing it for university education. Competitors are prohibited from selling their platforms for school education. Prohibited. But we want you to become excellent developers, so you need to become platform experts. Your business will grow. We've already copied everything. We need to make it this way. Then, as more platforms are added, we can continue to add and change them. So, now, Fold is essentially a platform. Machine. Yes. It's a single machine, and I'll copy it and run it virtually. So, while the live copy operation is pretty good, if you're smart, you can create a script file. You can create an SH file and write it. You can even write an SH script to automatically copy it during actual work. That's possible. The reason I explain this is because we need to find a library to use for the appliance. Why? We need to find an open source library for the platform, and we need to copy it and use it. Now, let's run the virtual machine once. Our virtual machine is probably here. Is it here? Right? Now, let's delete the folder. Oh, the volume isn't working. First, let's copy the file to the root folder. Do you think I can use Dakoshi CP? I'll copy the Dakoshi CP applet to my virtual machine and to the notes in my home folder. Now, it's copied here. You can copy it later. Yes, it's copied. Next, the play of Omerid. Now that the export path has changed, do the same for Parallel X Play. Then, run CM in the background and belt and boxy. Now, in the log and channel, it is in console mode, and the console log is being output and the cipher is being exchanged. Please try this far. Next, what is next is to have a virtual IP number that actually has a sound and capture the package. For now, I will do a simple capture in the state and do it later. And if the virtual type is okay, if you retarget it like this, the file will not be transferred and it will be initialized. So, I will capture the package using the test content, explain the network island, and finish the net education memory. So, do this once for package analysis. You can see it, and I hope you try what you just did. Let's try capturing a package in a virtual machine using T#. Capturing it is crucial to understand the exact principles of preprocessing. For reference, cans can also be captured. We'll match the package capture container to this. In the actual app, there might not be a utility for capturing packages when using a virtual machine or target. So, this is a virtual machine created with Woven. We've installed T#, which is required for package capture, here in 5 minutes. So, we can do it through commands, and we'll run a test virtual machine. When we run it, the ancestor is this. If we enter the container name in the net, we can use the same network as the existing virtual machine. As you can see, this is the virtual machine I'm using right now. First, we need to retrieve the network that the virtual machine has. Since it's hard to see, let's look at it like this. You can see the content is a direct copy of the network of the virtual machine in Twitch 21. If you name it test, like this, it will bring up the image. I created it. That's done, right? Then I'll create one more dimension. So, the name I just created is bash, right? That's right. Next, the virtual machine we're actually using is the same as before. So, the top one is for capturing the network on the virtual machine. For example, it's a virtual machine for XPay and X8. And the two below are virtual machines for pressure. Since there's no command to capture the virtual machine for pressure, we're using a package capture here instead. And if you type hstroke like before, a long one will appear. So, before we start, let's put it in like this and apply the package capture. The net devs and virtual net devs here are gone. So I captured it like this. Then I ran the 900th and the Galadone proxy captured it. You can see the numbers changing like this. I cleaned up the captured data and quit it with Ctrl+C. I cleaned up Ctrl+C, then the file was created. Double-clicking it will copy the real path. Yes, I copied the file here to the current folder using the copy command in the work folder. You can copy it like this. After copying, the captured file will appear in the work folder, right? If you click on it, you can see it like this. You can check the captured content. So, if you see this through the virtual machine, you can use the network bridge of the dock to create a virtual IP with a meaningful IP. After creating the bridge, you can set the two issues to static IPs and then handle communication between them. Once you've processed this, you can now capture a package for a specific issue in the same way as before. Then, if multiple issues exist, you can capture the network and check whether it's being captured normally. T-Shark and TGTCP dumps are the same. For reference, I just used T-Shark, and the TCP dump is the same. Canson has a separate can dump command. You need to capture using this command. Then, you can test everything. In particular, later on, you can test by connecting the virtual area to the actual board. If the actual target board and radio board are on the same network, the virtual board will have a unique address, so you can match them and test by connecting the virtual board and the virtual board. This way, you can receive and analyze the network data coming from the actual board. That's all for today's class.